So our today's topic is about differential equation, and this video is for those who are doing graduation or preparing for the competitive exams like JAM or any other MSc entrance, who are interested in learning about this interesting questions of these differential equations, and it's gonna help you really lot. And if you still have some problems regarding these, you may ask in the comment section. So let's start. So our first question is, consider the differential equation x plus y plus 2 plus 3x plus 4, 3y plus 2 times dy dx equals to 0. So here it is asking which of the following is true. So the options are like whether the given differential equation is linear, or it is exact, or this e to the power x plus y is an integrating factor, or a suitable substitution can transform this differential equation to the separable form. So let us begin. So here we can see that it is a first degree and first order linear differential equation. So as we can see here, if we'll put say x plus y is equals to t, then this equation may be transformed to t plus 2 plus 3 times t plus 2 times, here if we find dy dx, then 1 plus dy upon dx will give you dt dx. So here we can write dy dx in terms of dt dx minus 1, which is equals to 0. And from here we can also find like 3t plus 2 times dt dx minus 1, which is equals to minus t minus 2. And dt dx minus 1, which is equals to minus t minus 2 upon 3t plus 2. And if we will see, then dt upon dx, which is equals to minus t negative of 2 upon 3t plus 2 plus 1. So these can be put into the variable separable form, as it will simply give you like dt upon dx, which is equals to 3t minus t, that is 2t upon 3t plus 2. So 3t plus 2 upon 2t times dt is equals to dx. So it is variable separable form. The answer is D, which is the correct answer. So now the second question. So we have to consider the differential equation 2 cos y square dx minus xy sin y square dy is equals to 0. Then e to the power x is an integrating factor, or e to the power minus x is an integrating factor, or 3x is an integrating factor, or x cube is an integrating factor. So to check this, firstly we will see that whether the given differential equation is exact or not. So here it is m is 2 cos y square and n is minus xy sin y square. So first of all, let's find out del m upon del y, which is equals to negative of 4y sin y square. First of all, we will do cos y square in terms of minus sin y square, and y square, which will be 2y, so minus 4y. Similarly, del n upon del x is equals to minus y sin y square. So here we can use the formula like 1 by n del m upon del y minus del n upon del x, which is equals to negative of minus xy sin y square. And if we will subtract this and this, we will get minus 3y sin y square, which will ultimately give 3 upon x, which is a function of x only. So the integrating factor will be equals to e to the power 3 upon x dx, which is equals to e to the power 3 log x, ultimately x cubed. So the correct answer is D. So now comes to the third question. Here we have y1 and y2 be twice differential equation on an interval I, satisfying the differential equation dy1 upon dx minus y1 minus y2 is equals to e to the power x, and 2 dy1 dx plus dy2 dx minus 6y1 equals to 0. Then y1x, we have to find the y1x. So in finding the y1x, firstly we will gonna differentiate this equation so that we will get dy2 upon dx, and ultimately we will find dy to dx from here, and we are gonna put it here. So let's differentiate this with respect to x. We will get dy dx square minus dy1 upon dx minus dy2 upon dx, which is equals to e to the power x. So if we will put the dy2 upon dx value from here, we will get something like dy1 minus dx minus, and dy2 dx we will get here 6y1 minus 2 dy1 upon dx is equals to e to the power x. So if we will solve this, we will get like dy1 upon dx square plus dy1 upon dx, because -1 and +2 gives +1, and minus 6y1 is equals to e to the power x. So d square plus d minus 6 y1 is equals to e to the power x. For complementary function, we will get d square plus d minus 6 equals to 0, which will ultimately give you d is equals to 2 or -3. Then CF will be as c1 e to the power 2x plus c2 e to the power minus 3x. So for pi, we have 1 upon d square plus d minus 6 e to the power x. Simply we will put 1 in place of d, and we will get 1 plus 1 -6 e to the power x minus 1 upon 4 e to the power x. So the y1 x is equals to c1 e to the power 2x plus c2 e to the power minus 3x minus 1 upon 4 e to the power x. So the correct answer is C. So comes to the fourth question, which says one of the integrating factor of the differential equation y square minus 3xy times dx plus x square minus xy times dy equals to 0 is. So we have to find the integrating factor. Similarly, we can, let's say, m is equals to y square minus 3xy and n is equals to x square minus xy. So for exact, we have to find del m by del y. As this is, we have to check whether the given differential equation is exact or not. So we will get 2y 3x and del n upon del x. We're going to 2x minus y. As we can see that both are not equal, so we have to find the integrating factor, and its degree or is 2. It means it is a homogeneous differential equation. So we know that mx plus ny, which will ultimately give us xy square minus 3x square y plus x square y minus xy square. So this and this will be cut out, and minus 2x square y. So integrating factor will be 1 upon -2 x square y. So if we will see the form, it will be similar to 1 upon x square y, as minus 1 by 2 is a constant. So we can leave it, and it is the form of c x square y. So the answer is B. So that's all for today.